music is paused. I think I'm on. I don't know. Still don't know how this works. What's up, folks? How's it going? I hope you're all having a nice day. Today I am going to be taking a look at Cassandra's behavior on EBS, and this is a really interesting topic to me. I've worked on quite a few clusters that have used EBS, and there was a point in time where I used to say, don't use EBS. Around 10 years ago, my advice was, don't use SAN, don't use EBS. And there's reasons to stick with that, but if that's really kind of only if you are being super cost conscious and you don't want to use the newer instance types like GP3, for example. You can get great performance out of the IO line. You can get great performance out of. But one of the things for me is that's kind of like a sticking point is the cost. I mean, I think the cost is important. Oh man, I have to like resize my drives. Oh no, I'm gonna run out of space. All right, just give me a sec here. I have to stop this from going. I need to jump into my AWS control panel. I accidentally filled my disk with 90 gigs of data, so I have to quickly resize this thing before everything fails. Just give me a moment. Anyway, I'll just talk about what I'm up to today, why I care, what's going on. So I have worked on quite a few clusters in the past where the situation has been, hey, I'm using EBS and we're getting kind of unpredictable performance. But usually what you say is, well, increase your throughput limit on the volume. Now, this is okay. I don't really consider that to be the best option personally, because I would rather make things more efficient so we can not do that. So let's just modify this volume. I'm going to go ahead and turn this into a 500 gig drive. Modify. Let's see. So I need to just go ahead and quickly modify the rest of these disks. Oops. I know you can't see what I'm doing. I just don't feel like sharing my my AWS control panel here. I don't know. It's not that I don't trust the world and YouTube with everything that I have going on, but I don't. All right, modify volume. I will go ahead and I guess I'll just do the I'll share my screen. So share my window. So I have environment here. Let's talk a little bit about this environment. Let's see, maybe that. Yeah, let's go with that. Okay, so I'm over here, and let me just see if this thing is done yet. Oh man. All right, I'm just going to stop my workloads now. I have all these fortunately I have all these saved, so I can just restart them. No big deal. I just don't want to run out of space while this thing is going. So the point of today is to take advantage of to take a look at how Cassandra interacts with the file system, because I have a number of open issues that I'm trying to get, that I would love to get into 5.0. And those issues have been based on observations that I've made about the storage engine, how Cassandra reads data off disk. So what I'm doing today is getting some control data. I'm going to get some information about how Cassandra reads stuff off disk. And actually, let me just I'm going to take a minute here, and I'm just going to walk you through the stuff that I want to get in, because I think that these are really, really interesting. So let's see. Let's go with a different screen, because since I've got to wait for the okay. So this looks like it's kind of hard to read. Let's go smaller. Optimize I/O during table scans. So there's a few patches that I'm trying to get in, and it turns out they're all related. So let's see. Is this one? Hold on. This. So I actually filed this 5 years ago. God, 5 years. And this is kind of always, this has been a thing for me for a little while now. It's always bugged me that I've needed this. So here's the situation. There are certain operations, specifically streaming and compaction, where we read data off disk sequentially. That's like not a big secret that compaction is a sequential reads. Now there's a couple things here, and let's actually take a step back. The whole reason why I'm talking about EBS, and I'm specifically looking at GP3 here, because GP3 is really reliable, but you've got to pay for IOPS, which is fine, and you pay for your throughput. So the thing that I discovered is, and maybe discovered is not the right word here, but the thing that I found here is that when you read, because of the way that Amazon recognizes I/O operations, basically what it does is if you do a read off disk, that counts as an I/O operation. And if you do a really small read, like if you read 4K worth of data or you read 256K worth of data, it's actually the same accounting on their end. So they have, I don't actually know what they have behind the scenes that's counting this, but let's just suppose that they have some like rate limiter or they're counting it somehow. So every time you go to disk, it counts as a read. And when you're doing compaction and streaming, we read one chunk at a time. Now, a chunk is a compressed buffer. So basically, when Cassandra writes an SS table, assuming you're using compression, which you should be, that data gets compressed and it gets written to disk. The size of the compressed buffer is determined by the chunk length table setting on your table. So by default now, for a long time, it's been 16K, meaning that we fill up 16K, we compress it, we write it to disk, and we include the compression metadata. Cool, good times. The problem is that when we do compaction or when we do any read operations at all, we're reading just the size of the compressed buffer. So if we look at this JIRA, and this is Cassandra 15452, what we see here is we have this request size, IOPS, and throughput. So I took FIO, which is a Linux. It's the basically the tool that's used to do kernel benchmarking of the storage subsystem of the Linux kernel. It's written by Jens Axbow, I believe his name is, and he's the guy that maintains the storage subsystem. So he's a smart dude, and he wrote this like really awesome utility that I rely on all the time. And so this is a test that runs sequential access. And what we see here is if we perform 4K reads, so this drive was configured with 128 megs of throughput and 3,000 IOPS. What we find is that we actually hit our throughput limit. We hit our IOPS limit before we even come close to our throughput limit when we're doing 4K reads. We increase the size to 8K, then we get the same number, roughly the same number of IOPS, but we get double the throughput. So this number goes all the way, this goes up and up and up until we reach a certain point where we at 256K, we're only doing 478 IOPS in order to get 128 megs a second. So basically what this tells us is that for compaction, when we're compacting data from a bunch of SS tables, we want to be reading data in chunks of 256K at a time, because that's just what the EBS specification says. So if we maximize the data that we're reading, then we reduce the number of IOPS that we're using. So if we can go up to reading 256K at a time, then we can improve compaction. Now the problem here is that that's actually a little bit tricky. So a lot of the times people will say, hey, that's what read ahead's for. But read ahead's actually pretty terrible. Like read ahead is not particularly great, because if you have like kind of a mix of tables and one is doing a bunch of writes and one is doing a bunch of reads, the compaction, like you can either have compaction get a lot of throughput, and by setting read ahead kind of high, you can either optimize for compaction or you can optimize for reads, but it's like one setting. It's like a hammer. It doesn't make any sense to have this one setting that you use that is like one thing is good and the other is terrible, or the other way around, or some kind of mediocre middle ground. It's actually a lot better if we can maximize the IO and compaction, and when we do reads, we minimize IO. Now, this also holds true for repairs, it holds true for range scans, and it holds true for large slices that might go past a single chunk boundary. Now, that might not happen. You might not be returning more than 16K worth of data at a time, but you might be. There's nothing that says 5,000 rows are going to fit in one chunk. That doesn't compute, because that would mean that each row would only be like a few bytes, unless my math is off. Could be. Someone correct me if I'm wrong here. So what are we at? So that means that the goal should be to make it so that in compaction, we use an internal buffer and we read 256K at a time. Now, there's actually another side benefit to this. Going out and reading data out of your system, like doing a system call to the file system, is a lot slower than just reading data out of an internal buffer. Like an internal buffer is going to be the fastest way you can read it. So that's what we should be using. That's why within Java, there's a buffered reader. It's literally what it's for. But Cassandra, we don't have that. We have a whole bunch of like internal stuff, kind of like custom built, to make Cassandra work. So Let me just check now. Maybe I can resize my volumes. Okay. This is optimizing still. Poor planning on my part. I actually I had some failures trying to launch these instances, and it took like half an hour to get them up. So that's annoying. Anyway, I think what we can do here is I'll just trigger some read-heavy workloads while this thing is running. Or maybe I can resize it now. Maybe that's okay. Let's just take a look. I'll just try and resize it. I don't use XFS grow all the time, so I've got to like make sure I'm doing this thing right. Okay, so let's just see what happens here. XFS. Look at that. What did it do? Oh, great. That was easy. Okay, let's just do that. We'll just do that in a moment. So I'm just going to hop out of here. See all. See if that works. Never tried that on. Oops. Okay, so what I'm doing now is just I'm telling it to grow to the maximum size. Cool. Okay, so we're all grossed up. Let's hop back in here. So now, because I don't think I have any more. Oh, look at that! I'm still running, and it's not actually doing anything. So that's sweet. Let's go ahead and we're gonna run these workloads. Now I'm gonna run this, but I don't actually need the populate. So let's just do this. No, I'm not gonna do it. And I'm gonna get rid of this. I'm intentionally gonna put probably more work on this cluster than it can handle. There's one thing that I discovered in that if I use my really fun like rate limiter flags, and there's like multiple processes, they'll kind of like seesaw around each other. So let's just get this one started. So this is a read heavy workload, doing random partition access. So this is just going to get started over here. Boom. Okay, that's going. Second workload. So this is going to end up doing. We're going to be at 70,000 queries a second. Now, let me just. Oops. So just to set the stage here, so this is just a 3-node cluster. This isn't anything crazy. Because I'm testing, my test is a because this is a test of disk throughput. There's no need to have a big cluster here, but there is a need to have a decent amount of data. So, oh boy, this is fun. This has a bunch of, this is behind. Am I running other workloads? So this is running, it's not doing a lot. Only one. Oh, it must have been overloaded from before. So speaking of overloaded, let's see what's going on. There's a really interesting patch that this one. Oops. As you hear snoring, that's my dog. Unbounded queues in native transport requests lead to node instability. So I filed this one a few weeks ago, back in April. And I've got some really, really good performance metrics around this. Essentially, like if a node becomes unstable, this is the thing that can help bring it back a lot faster. So Cassandra 5 should be significantly improved from a stability perspective. It's a few people looking at this right now, so a lot of eyes on this. I tend to report things as opposed to commit code. I just don't really. My free time, I don't have like a lot of. I don't have enough time to commit code. I just don't. That's not what I do in my personal time. Occasionally I do if it's a customer thing, but so let's see. Is this thing done? Oops. Okay, cool. So it was just running a match. So I've got one more session in this series after this week. So next week, I'm actually going to be looking at the results. There is a patch that I'm going to be taking a look at. Hopefully it looks good. Hopefully it looks good. Okay, so this one's all set. So let's just go ahead and start this back up. And grab one more. What did I start writing? This one's a, oops. Okay, so I think I gotta run this one now. Whoa, look at all that. Look at all that time in IO8. This is exactly the problem that I'm trying to solve. Perfect. So I got some data and I got it live on the stream. Let's just save this. Gotta save this. This is great. It is amazing. There's so much time spent in IO8, so let's take a look. Before it goes away. Okay, so this drive was configured with 3,000 IOPS, okay, and it's hit this limit, okay. So what we want to know is why is it hitting that? So what we're going to do is we're going to use a tool called XFS Slower, okay, and so now this is, oh my god, this latency is terrible. So let's see what it's up to. Let's see what it's up to. Are we running compactions? Yes, we have a whole bunch of compactions. Oh, this is amazing. This is amazing. I'm actually going to stop this workload. Okay, so if I do this, I can look here. I can see that there are, so I'm going to wait for this to die down. This is amazing. So once there are no, this is the entire point of this. So what we can see now is that I have compaction really going. It's compacting a bunch, and I'm not even doing anything else. Okay, so I can see this. And then the IO stat numbers are here. So I'm getting 1,400 IOPS, and that's just from compaction. Now, if I go ahead and I say, let's just say I set it to like, I don't think we're gonna see 256 ever. But I am curious. So let's take a look at the, okay. So XFS Slower, really cool utility. I should add a nice little wrapper for this. It's amazing. I'm so excited. I'm so excited for this patch. You have no idea. So Cassandra is about to get so much more performant. Like this is going to happen. So let's see. So let's just take a look. So first, let's just do XFS dist. So what this is going to show us is distribution of the response times coming off the file system. So not particularly awesome. Brutal. Okay, so we're seeing here that like we have responses that are coming back and it's like taking forever, right? So let's just also now look at, so that's from the file system. So now I'm going to use biolatency. So biolatency is going to give me the distribution of response times at the block device level. So we have a bunch of stuff coming back at probably in reasonable times. And then we've got all this stuff that comes in like ridiculously bad times. And this is just compaction. So if I add this workload back in, so if I start doing 50,000 requests a second, we become bottlenecked so fast. Wow, this is great. Okay. Now you can see here our latency numbers are completely terrible. It's really wild how this actually kind of ties into everything I've been talking about, because these numbers right here, these are milliseconds. So we're getting like responses back in like tens, dozens of milliseconds. Like this is 32. Look at this. The bulk of these requests came in between 16 and 31 milliseconds back. So I didn't even have 10,000 requests a second running. And between compaction, chewing up IO, and the reads, performance is atrocious. So this is what I'm looking to address is this case, but also just generally making it more efficient. So we're going to also be doing a test on range scans, trying to get like if you do Cassandra, I've often said Cassandra is not great for analytics. I'm pretty sure this is one of the reasons. So I need to get a range scan test built into EasyCast Stress. I added one, but it's not great. I'm going to add a little bit more to it. That's going to make it a lot better. I'm probably going to work on that today. But what we're going to see is with the reduction in IO from compaction, we should see a significant overall improvement into the performance here. So it's remarkably easy to see this. Like if we just go, I've got compaction throughput set to 256 over here. Let's just see what that. Like if I do, so here, I'm just going to jump on another node. I always get it wrong. Proc says VM drop caches. Okay. The latency is just going through the roof. How is everyone today? All right. So here's what we're seeing here. Um, we uh, I am like overjoyed that I'm seeing this right now because it's exactly what I wanted. We have crap latency. We've got compactions going nuts. We've got tons of errors over here. So basically, what can happen is that this is a prime example of how IOPS limited disks can um, completely kill your database. And this is one of the reasons why people are like, you don't want to use Cassandra on EBS. And then people do all sorts of interesting tricks, like let's make sure that our working set is able to fit in page cache. Well, that's only good if you have a tiny working set. Like if you're following the 80-20 rule, great, and you're willing to give each box 100 something gigs of RAM, fine. But fundamentally, it's all workarounds for storage engine efficiency. So if we do this and we do something else that's really smart, which is include an advise that we don't need the data that's being compacted, then we will reduce the pollution that goes into the page cache, because we basically bring a bunch of data into the page cache, it evicts other things, and then we delete the file. So it's like the worst. It's just completely pointless. So essentially, this patch, there's another level of optimization that can come after this, which is we should be using direct IO for compaction. So that's fine. We can absolutely do that too. There's just no, like, that's kind of a lot. Like switching like the way that you read, like reading into a buffer is one thing. Switching to direct IO is a little bit. It's a little bit more. And this late in the game, that might be a little bit of a big ask to just start like throwing direct IO compaction into the storage engine. But this stuff seems pretty reasonable. So anyway, I'm just going to go here for another 15 minutes and just take a look at a couple more things. So it looks like compaction's finished. I'm going to just start letting this thing go. So just start ripping it up here. Let's see this one again. Okay, so what's cool about this is if we get this in, we actually get if we get the results that we're looking for, we will have compaction. We'll just have overall the storage engine will be more efficient. And then the other thing that's really cool about it is this patch that's going to fix the native transport requests when they back up. Will make it so that things fail a lot. Like the requests will time out a lot faster, more aggressively. They'll basically be like pruned out. And the really cool thing about that is it means that the amount, like the surface area for Cassandra to run into problems is going to significantly decrease. And we should see overall 5.0, if we can get these things in, should be significantly more reliable and cheaper to run and just better. So I'm pumped. You know, if you're interested in if you're interested in learning more about this, come to my training. Or watch all these, whatever, your choice. All right. So this is going over here. See, my performance is not great. Honestly, I think I have the numbers that I need out of this. So if there's any questions, throw them in the comments. I'm happy to answer questions about stuff if anyone has any questions. Because I've gotten what I need out of this. I've managed to figure out that this is in fact the exact problem that I've said it is. It makes me feel good. So let's just see. So see how this is backed up native transport requests. So if I just go ahead and I say, all right, let's just stop. Okay. And you know what? Instead of doing a read workload, I'm going to push a write workload. Let's get this one. Just time series. Okay. All right. So now I'm doing far less from the standpoint of from reads. So the interesting thing here is to have one workload that's a lot of reads and one workload that's a lot of writes, and that's where things kind of like fall on its face. And we are actually seeing reasonable rates of compaction. Oh, I'm only doing 20,000. All right, I'm just gonna go nuts here. I'm gonna do let's do 100,000 requests a second. Actually, no. I'm gonna tell it to 200,000 requests a second. We'll see how high it goes. It does like a warm up phase, so it'll gradually increase, and if it reaches a point where like it can't get to 200K, like reason and like it just won't. Like it won't try. It won't just destroy the system. It'll slowly ramp it up. Okay. All right. So now we're at 45,000 requests a second, and we are doing some compaction here. So I'm using, might as well just show you what I'm using here to run this test. As always, doing everything using Easy Task Lab because that's what I built it for. So here's everything here are all the, let's see. And you know, I could actually do more concurrent writes. So let me just do this. Just do a lot of concurrent writes, and then I don't think we're definitely not going to get This is never going to happen, by the way. This 512 is literally never going to happen. But so the patch file can be applied to the entire cluster, and then I use -- restart, triggers a rolling restart of the cluster. So basically what it does is it restarts, it takes the original YAML, applies this as a patch on top of it, replaces the current YAML, and then runs a restart. And the restart waits for port 9042 to be available, and then maybe waits for, yep, there it is. Boom. Maybe waits for another second or something, but pretty aggressively takes things out. So I don't feel like waiting around. So it's like I'll get like a couple errors back, but I don't really care. So compaction, Cassandra should be up right now. Yep. So what's kind of cool, there we go, drop some cache again. Boom, dropping the cache, everything starts to look terrible. All right. So then I think a logical question is, what's being read? So let's just do this. I'll show you how to do this. This is a nice one. So XFS slower is a really useful command. So if I do that, and then I'll say let's stick to 5. Okay, so I'm just going to stick to, I only want to 10. We'll just see some operations. All right. So if you're wondering how to figure out like what is going on, why are things slow, like what is actually slow, XFS slower is pretty cool. So you can see here that it's amazing. All right, I think that this is actually my like only workload that I'm running. So I'm doing like 90,000 requests a second, but my latency is terrible. And then I look here and I can see I'm spending a ton of time in IO wait. Not particularly great. This disk is definitely reached its throughput limit. Actually, you can see here it says 256 megs. That's actually the throughput limit of the disk. It's not even the IOPS limit. All right, short stream, everyone. Short stream today. I'm wrapping things up. So here's what I have here. So I'm going to save this data because I'm actually going to be running more tests. Basically, what we see is the performance not particularly great. So what I'm going to end up doing is taking a patch that should fix this particular issue, and I'm going to be trying it out. So I'm going to be running a mixed cluster. So it will one will have it, one won't. So I'm going to be able to get some A/B tests to see what happens here, so I can actually get a feel for how this behaves, and that should be a lot of fun. We should see a reduction in the amount of IOPS used, and that'll be fun. So basically, this will work better for a bunch of things. Good times. I'm curious. Oh, read ahead is on here. Why is read ahead? That was supposed to be disabled. So with it enabled, that's probably why my read latency is so bad. It's funny, I don't think that'll work. Restart Cassandra. Cassandra is back up. So all right, I'm wrapping it up. I've got my data. I'm going to let this run, and I'm going to be testing this EBS patch. So hopefully we can get some better results. And in an ideal world, next week I will have a mixed cluster that so we can compare the results of what's going on with two. So I think I'll actually do 3 configurations. I'm going to do, don't hold me to it, but next week it'll be 1 node with read ahead on, one node with read ahead at 4, existing 5.0, tip of 5.0, and then one node with read ahead off with the buffer patch. So that'll give us 3 data points. So the goal is to maximize compaction throughput while minimizing the overhead of reads. So, all right, I'm going to get to that. I hope you have a fantastic day, and I'll see you soon. All right.